When you look up at a night sky, it's easy to get lost in the beauty of the stars. But they are just a taste of the endless marvels out there in the cosmos. Invisible to the naked eye, there are things you won't believe. Places where truth really is stranger than the strangest fiction. Out there are immense clusters of stars. Stellar nurseries from when stars are born. Supernova remnants from when stars die. Black holes and other curiosities that have puzzled scientists for centuries and still do today. These are just a few of the wonders of our universe. I'm Damon Scotting, and this is Astronomical. Do you see that right there? That is the Orion Nebula. That is the reason I got into astronomy. That is one of the main reasons that I'm here today. Because when I bought my 4-inch telescope after passing my GCSEs, the first thing I found in the sky after the moon was that. And when I saw it through a telescope, it appeared grey. A few tiny stars inside of it, but I could make out structure. I could see it was a cloud of dust and gas. And then when I read about it and heard it was a stellar nursery, and that's where stars are born, that sticks with you, captivates you, it moves you. And that's why I've been hooked on astronomy ever since. Because of that, right there. And you know what, it's been under my nose this entire time. Every time we look at the constellation of Orion, we look straight at the belt, just here. But the real wonder is just below the belt in its sword. The Great Orion Nebula is one of the wonders of our universe. It is here, deep within the clouds of dust and gas that can stretch for hundreds of light years, that stars are born. Big, small, red, blue, all stars are birthed in the same way. When certain areas of these colossal clouds condense and coalesce, nuclear fusion occurs as the lighter elements are fused into heavier ones. This is the process in which stars generate their energy. These are 3 different images that I captured of one of our nearest stellar nurseries, the Orion Nebula. At the core, visible through the aid of a telescope, is the centre for stellar birth. Stellar nurseries are arguably one of the most beautiful sights in astronomy. Think of all the countless solar systems that are being born right here. Stars rarely form on their own, however. It is far more common for them to form as a group of stars, known as a star cluster. Okay, it should be about that. Yes, okay, alright, so there it is. There we go. So this is the Great Globular Cluster in Hercules. It's a collection of several 100,000 stars that are very densely packed together. In fact, the diameter of this cluster is just 145 light years. To put into perspective for you, if you compare this to the Sun's neighbourhood, then these stars are 100 times more densely packed together. They are so close to one another that they often collide and produce new stars. Star clusters are extremely large groups of stars. They typically come in 2 forms, either a globular cluster, where the stars are packed together in very tight groups of hundreds to millions of very old stars, or open clusters, which are a lot less densely packed together, containing a few hundred, which are very young. This is a Pleiades star cluster, also referred to as the Seven Sisters. It's one of the brightest open clusters in our night sky and easily visible to the naked eye. Here's a picture I took of comet pan-stars passing by the Pleiades. This is a live shot of Caldwell 14, a double cluster. It's another cluster that's easily visible to the naked eye and all the more remarkable when viewed through a pair of binoculars or a small telescope. Open clusters are rarely older than 50 million years, as they are often pulled apart easily due to their loose gravitational bounding, whilst globular clusters are typically 10 billion years old, and were amongst the very first stars to form in the universe. They are all the same age, and as a cluster they orbit on the outskirts of galaxies, meaning they remain tightly bound, uninfluenced by other bodies. Globular clusters are truly a wonderful sight once viewed through the telescope, whilst open clusters are the naked eye gems of the night sky. Regardless of which you prefer, star clusters are a wonder of the universe. Out there, lurking in the darkness of the universe, there are monsters. These wonders of the universe don't obey the rules of physics. The very laws that govern the universe we exist in break down the closer you get to them. They feast on everything. Nothing is spared, not even stars. This is a black hole. This is a gravitational well. This shows how space is warped by matter. Now in this example we're going to say this is a black hole, and these are stars. Now black holes are incredibly dense and take up small regions in space, but they have a mass equivalent to millions or even billions of stars. So as you can tell, the black hole is warping space, and this is an object of relatively insignificant mass compared to the black hole. So although a star will have its own distortion of space, similar to this right here, compared on a grand scale, it seems almost invisible. So when we put a star near a black hole, it begins to orbit as it falls into the center, where the gravitational pull is so strong that nothing, not even light, can escape its pull. This is known as the event horizon, and what goes in never comes back out.
Black holes form when high-mass stars reach the end of their lives and collapse under their own gravity. They really are the most bizarre things in the universe. They are places where truth really is stranger than the strangest fiction. Looking at it, what you're really seeing is the event horizon. The region around a black hole where the gravitational pull is so strong that nothing, not even the fastest thing in the universe, light, can escape its grasp. It truly is the point of no return. But what lies at the center of a black hole? Many people have different theories about it, but right now we believe there is a single infinitely dense point of mass in space, known as a singularity. We may never know for sure, as there is no way to witness a naked singularity, to cross the event horizon and see beyond, and in return is restricted by the laws of physics. Recently, however, we obtained our first ever true image of a black hole, confirming many of the theories we had. The orange region around the black hole is the accretion disk, formed when stars pass too close and are ripped apart before being swallowed. This is a representation of how a black hole looks from different angles. They distort space-time and bend light. In our galaxy, there are millions and millions of black holes, invisible, with nothing to light them up. One of the ways we can see these black holes is by observing their gravitational influence, noting any stars caught in orbit around them. Black holes will be the last thing left in the universe.
Now, the idea of two suns setting below the horizon might seem like something straight out of science fiction, but it's actually more common than you may think. In fact, recent evidence suggests that multiple star systems, where two or more stars orbit one another, are more common than singular star systems like our Sun, which are all alone. So if you were sat upon a planet orbiting a binary star system, then sunsets like this would be a regular occurrence. On Earth, our temperature is mainly determined by our axial tilt. Assuming you're not on the equator, then the amount of sunlight you receive during the year varies dramatically, and so do the temperatures. But another big factor is the distance a planet is from the Sun. Fortunately, the Earth orbits in almost a perfect circle around the Sun, which means it receives the same amount of light and heat throughout the year. But the same can't be said for binary star systems, because planets orbiting around these would have a chaotic orbit. It may be a very stretched circle that varies continuously, or it might even be a figure eight as it goes in between the stars, which means the temperatures will vary extremely on the surface of those planets. And if that wasn't complicated enough, star systems like this can contain 3 stars, 4 stars, 5 stars. Star systems can contain as many as 6 stars that we know of. A sextuplet star system, a true wonder of our universe, and one is visible to the naked eye.
When looking north, one of the first things you notice is the Big Dipper. Shaped like a saucepan, the Greeks named the constellation Ursa Major, meaning Great Bear. In the handle of the Big Dipper, you can see 2 stars very close to one another. 13th century Arabs used these stars to test people's eyesight. Although they appear as just 2 close stars, they are actually 6. This is Mizar and Alsor, a quadruple and binary star system that together form a sextuplet star system. Binary star systems can come in many different arrangements. They can be 2 of the same mass orbiting a common centre of mass. They can be slightly different in mass size, like the Pluton-Charon system. There can be more of a difference in mass, like Earth and the Moon. Or an even bigger difference, an extreme difference, like Earth and the Sun. Maybe they're even the same mass, but they both orbit in an eclipse, with a common centre of mass between them. This is Albireo, which to the naked eye appears as just another star, but with the help of a telescope it is resolved to be multiple stars. Known as one of the best sights in the night sky, it is easily made out for a pair of binoculars, showing a stunning contrast between the red and blue. For centuries we've been limited to appreciating the beauty of the cosmos with just our naked eye. Now we are able to resolve the countless wonders of the universe with tools like telescopes and binoculars that our ancestors could only dream of. These marvels have only become known to us in the past few centuries, but they are just the tip of the iceberg in terms of the true wonders out there that are waiting to be discovered. When high-mass stars reach the end of their life, they tend to do something pretty special. This is a supernova, the brightest explosion in the universe. When they happen, they will outshine the entire galaxy before dimming down. The aftermath of a supernova can be either beautiful or terrifying. The size of the star will determine what happens to it after it explodes. Supernovas occur when a star runs out of fuel. Throughout its lifetime, it is in a constant balance between the outward force of radiation and the inward pull of gravity. As the outward force of radiation begins to run out, gravity wins over, and the star collapses inwards on itself, before it either rebounds to produce a supernova remnant, or, if the star is extremely massive, a black hole. The speeds at which the star collapses are fairly close to the speed of light, but the afterglow of the explosion can outshine their host galaxy for weeks. This is the Crab Nebula. It is a supernova remnant, a star that went supernova in the year 1054. It was recorded back then by Chinese astronomers and described as a second sun in the sky. That's how bright it appeared to us here on Earth. So how common are supernovas? Well, typically we expect a supernova to occur in our galaxy once every 100 years. However, we haven't observed one since the year 1604, which means we're long overdue. One star that could potentially be going supernova very soon belongs to the constellation of Orion, and is one of the brightest stars in our night sky.
Now, one of the most iconic parts of the constellation of Orion is Betelgeuse. Now you'll see Betelgeuse on the top right hand side here. It's known as a shoulder star. Betelgeuse is a super red giant. And the reason that's special is because it's on the verge right now of going supernova. In fact, it may go supernova anytime between now and 1 million years or so in the future. Now, because Betelgeuse is relatively very close to us, only 430 light years away, when it does go supernova, it will be visible to us during the daytime. In fact, it'll appear as a second sun. Odds are Betelgeuse could shine as bright as a full moon. But this only lasts for a couple of days, because supernovas are very short-lived flashes. In fact, some of them can be brighter than the core of a galaxy. When you think the core of a galaxy is a black hole swallowing thousands, maybe even millions of stars, ripping them apart. So for a supernova to be brighter than that, means it's something special. Now, when supermassive stars reach the end of their lifetime, they tend to go out in one of two ways. The really massive ones, with a mass more than 30 times that of our Sun, will form a void in space known as a black hole. But then those that aren't quite as massive, but still have a mass between 10 to 29 times that of our Sun, will form one of the densest objects in the universe. This is a neutron star. Immensely hot, with a mass 1 million times that of our planet, yet only a diameter of 20 kilometers, less than that of most major cities. These are incredibly dense.
The pressure at the core of a neutron star is very intense. The particles that would normally repel each other in any other circumstance are forced together. Protons and electrons fuse to form neutrons. Neutrons have no net charge, meaning they can get as close to each other as they like, leading to these stars being amongst the densest objects in the universe. They have magnetic fields that are trillions of times larger than that on Earth, which is what makes them easier to detect given their small size. In our galaxy, there could be as many as 100 million neutron stars.
Now, in order to show you just how dense neutron stars really are, if you were to take a sugar cube of neutron star matter, then it would weigh the same as Earth's tallest mountain, Mount Everest. This little sugar cube would weigh the same amount as every single human being on planet Earth. All 7.8 billion people would weigh the same amount as this sugar cube of neutron star matter.
But as if they were not enough of a wonder, something truly astonishing happens when two of these stars get too close to one another. They collide and produce what is known as a killer nova. Recently, there have been suggestions that most of the heaviest elements in the universe were not formed from supernova explosions, but instead from killer novas. The likes of gold and uranium form when neutrons become freed and almost immediately coalesce to form these rare elements. There is still plenty to learn about neutron stars, but even now, they are a wonder of the universe. Over the past century, we have solved a lot of the big mysteries in science. Ernest Rutherford discovered the atomic nucleus, Edwin Hubble discovered that our Milky Way is just one of many galaxies, and Watson and Crick revealed the true structure of DNA. But perhaps the biggest unsolved mystery facing science today is what the universe is really made of. Everything you see around you is made up of matter. Matter is anything that has a mass and takes up space. But when we look out into the universe, things don't quite add up. There simply isn't enough matter for things to be the way they are. Galaxies shouldn't really exist, as normal matter isn't strong enough to bind them together and form their complex structures. Something else is out there. Something that doesn't produce or reflect light. So we have decided to call it dark matter. It makes up 85% of our universe, as opposed to the 15% that is normal matter. If it weren't for dark matter, then galaxies would not rotate as fast as they do and stay grouped together. Instead, there would be a random arrangement of stars across the universe, as opposed to being a part of supermassive clusters that are galaxies. It does interact with gravity, and as far as we can tell, there must be a lot of it. It seems fair to assume that dark matter is made from an exotic particle that simply doesn't interact with light in any way that we have encountered before. We know very little about it, but it is crucial to understanding the universe and everything in it. In the same way that discoveries about the atomic nucleus and the existence of other galaxies have shaped our understanding of science, it seems only right to assume that when we do one day solve the problem of what dark matter really is, it will become a true wonder of the universe. But for now, it is a mystery.
Space is mostly desolate. It is incredibly vast, but the majority of it is completely empty. However, in the dark stretches of our cosmos, there are infrequent glimmers of hope. There are islands. Islands containing billions of stars, billions of other solar systems. These are galaxies. Massive collections of stars, stellar remnants, interstellar gas, dust, and dark matter, all bound together by gravity. And at the core of almost every single galaxy is a supermassive black hole. Around the central regions are the red dwarfs. These are amongst the oldest stars in the universe. Whilst the outer reaches of our galaxy is filled with young blue stars. The Milky Way is an average-sized galaxy. It has a diameter of 100,000 light years. Galaxies come in many different shapes and sizes. Here are just a few that I've imaged through my telescope. Now the universe is expanding at an accelerating rate. The galaxies are moving further and further away from each other. And one day, we may be unable to visit another galaxy because the space between us is so vast. But one day, we will visit another galaxy without having to ever leave our solar system. In about 4 billion years' time, our nearest spiral galaxy, the Andromeda Galaxy, will merge with the Milky Way. The Andromeda Galaxy contains 1 trillion stars. It's 2.5 times larger than the Milky Way. It will light up the night sky like never before.
The result of these two galaxies colliding will be a new galaxy that is very different to either of them right now. It will be called Milkdromeda and will resemble a giant elliptical galaxy. During this process, it is possible that our own sun may be flung out of the Milky Way into interstellar space.
Now when these two galaxies merge, it is very unlikely that any of the stars will collide with one another. And that is because the space in between the stars is incredibly vast. One thing is for certain though, that if anyone is left behind to see this spectacle, then they will be able to truly appreciate what is one of the wonders of our universe. I'm Damon Scotting, and this was Astronomical. and still do today. These are just a few of the wonders of our universe. Okay, let's go again. That has just went all down my jeans. There's a collection of several 100,000 stars that are densely packed together. So dense, in fact, that our diameter. Okay, let's go again. It will truly be a sight to behold. Okay, damn it, 3, 2, 1.